And this is where something special is going to start to happen. So the behaviour of the light wave at the boundary is going to change at a specific angle of incidence that we call the critical angle. So let's say we've got a ray coming in at the critical angle, and let's just label that on. So I've said the behaviour is going to change, but I haven't said what's going to happen to it yet. Well, it turns out that there is this critical angle where the refracted ray points along the boundary. So the critical angle is an angle that's so large that the refracted ray isn't really even going into the other material anymore. Instead, as we can see, it's moving along the boundary. So we've got this weird behaviour of the ray of light when we reach this critical angle, which leads us to the question, what happens if we have an angle of incidence that's even larger than this critical angle? Well, at angles bigger than the critical angle, the light ray is totally reflected. So we've got this reflected ray of light now. And remember that for reflection, the angle of incidence is always equal to the angle of reflection. So that's the angle of incidence, and we've drawn it here to show that it's the same as the angle of reflection. Notice that the reflected ray has gone straight from pointing in this direction to flicking up to here. It hasn't gradually moved up in this direction, because as soon as it's a reflected ray, the angle of reflection needs to equal the angle of incidence. So we're saying once we're above this critical angle, no light gets through to the second material. All of the light stays in the first material. So in general, if we have a light wave which is coming to the boundary at enough of an angle...
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific GCSE physics and combined science videos, just click on the Snap Revise smiley face. Join me today and let's make physics at GCSE a walk in the park.